Planets! Everyone loves them and everyone has a favorite. What's your favorite planet? Is it the one that gave us Weezer? Is it the one whose name has unfortunately completely overshadowed any discussion of the planet itself? Or is it Pluto? But that's besides the point. The question we're asking today is, which one is the largest? It's Jupiter, right? Well, yeah, kind of. Huh? What do you mean, kind of? It is the biggest planet. Well, in the solar system, yes, Jupiter is indisputably the biggest. But the solar system's 8 planets are only a small fraction of the total number of planets that we know of in the overall universe, of which we know around 6,000. That's a lot of planets, and they could contain any number of things. A copy of GTA 7, My Will to Live, the milk your dad went to the store to get. There's no telling what stories these mysterious exoplanets are waiting to tell us. And one of those stories pertains to size. Despite what I've been told, size does in fact matter, at least pertaining to exoplanets, and whether or not they're even planets to begin with. A popular fact is that once an exoplanet swells to a size of around 13 Jupiter masses, then at that point it's not a planet. But it's also not a star, it's instead a brown dwarf. A brown dwarf is a celestial body around 13 to 80 Jupiter masses that doesn't have enough mass to begin nuclear fusion like a main sequence star, but does have enough to begin fusion of deuterium. And while this fact is kind of true, it's not as clear-cut as it might seem. One of my personal favorite exoplanetary systems is Upsilon Andromedae, and one of its planets, Upsilon Andromedae C, which is named Somme, has a mass of 13.98 Jupiter masses, yet it's still called a planet. So what gives? Well, this is the moment where I kind of spoil the answer to this video's question. The question of what the biggest planet is isn't a question with any right answer. Because for planets on the level of Somme, another factor to the equation of their planethood is how they formed. Brown dwarfs form from the same way that stars do, via the collapse of cosmic clouds of gas and dust. They just don't gather as much mass as stars, meaning that they can't ignite, so to speak. But if an object forms orbiting around a star in a protoplanetary disk, then, well, we don't really know what to call it when its mass gets to that level, besides maybe a planetary mass object. But without a proper set definition of what it means to be planetary in the first place, this term, too, isn't perfect. So with that out of the way, I guess we can reword the question to something slightly more answerable. What is the largest known substellar object? Meaning, what is the largest known object that is smaller than a star but not a star? Well, from my research, the answer seems to be SDSSJ0104 plus 1535. Catchy name. Discovered in 2017, this celestial body seems to be the most massive one that we know of that is not a star or stellar remnant. And its mass? 90 Jupiter masses. You might remember that the mass range I gave for brown dwarfs was 13 to 80 Jupiter masses. So at this size, shouldn't SDSSJ0104 plus 1535 be a small red dwarf star? Well, no, not really. Ultimately, mass isn't the only factor when it comes to determining what an object is or isn't. Another example is G-type stars, the most famous being our Sun. It's often said that their mass is between 0.9 and 1.1 solar masses. Sounds good, right? Well, another famous example of a G-type star is Tau Ceti, and its mass is 0.78 solar masses. It just has to be not like the other G-type stars. Here, the question of whether or not a star is a G-type isn't just down to its size and mass, but the type of light it gives off. So even though we have a set mass range for them, it's not true that every single one will necessarily fall neatly within it. Things are just complicated. So what's the message? Size doesn't matter? I suddenly feel much better about myself. Or is it that planet is a meaningless term? Is Pluto thus still a planet? Someone should really make a video about that. Well, I don't know about that video, but I do know that this is the end of this one. As always, thank you for watching, and I hope you enjoyed and learned something. Until next time.